seat, and welcome again to the ribbon cutting ceremony for the Faculty of Engineering and Technology Mechanical Lab. All right, please welcome Dean Dr. Kofi Dalrymple as he comes to bring the welcome remarks.
Thank you so much. You know, we've been asked to have a medical, biomedical engineering program. So maybe she's speaking about the future, right? All right. Let me make a couple of remarks. Good morning, everyone. Our Vice-Chancellor, esteemed Vice-Chancellor, Ms. Lasawhna from Exxon, head of department, and other colleagues, students especially. And it's so good to see Mr. Haynes here today. So it's such a good pleasure. I'm happy this morning to bring these brief remarks. It's such an important occasion. Today really marks a step forward in our ability and really strengthening our capacity to deliver world-class engineering education right here at the University of Guyana. And thanks to the generous support of ExxonMobil, we are very, very proud to receive the equipment that are here. A welding plant, which we will see here, 2 lathes, an industrial grinder, and a bandsaw. And the students were displaying it for me earlier. But I really want to say that these tools are more than machines. They're not just machines. They're really the instruments that our students will use to shape their skills and to translate theory into practice, as well as to prepare them for the needs of what is really a growing industrial and technological landscape. And so this donation is we've been working so well with Exxon. I think just a few weeks ago, I think we were walking around with some folks from Exxon, and really you have to see the bigger picture, even though there's a small gathering here today. This is an important, maybe small, but important part of a wider vision that we share with Exxon, which is to build a strong, resilient, and self-sustaining engineering workforce right here in our country. And so on behalf of the Faculty of Engineering and Technology, I extend sincere thanks for this investment in our students, in our faculty, in our institution, and overall in our country. So thank you very much. We look forward to getting these machines to work, not just shaping lives, but shaping careers as well. So thank you.
Thank you, Dean. I'd also like to acknowledge Ms. Prescott. Thank you, Dean, for acknowledging her. Vice-Chancellor, Assistant Dean Bashir Khan, former Dean, swirling class, who is Kofi's right hand, it seems. And HODs, Anna, Ms. Trim, and if I missed your name, I am so very sorry. But I acknowledge you. And our students, our lovely students who've been here since this morning. Very early, 7:30. Yes. No idea why. All right. Please welcome our Vice-Chancellor, who will come to bring the background on this mechanical lab and this partnership with ExxonMobil to deliver this.
Thank you very much, Joelle. I'd like to recognize, apart from the present dean, the 2 past deans who are here, and a very special person who is Mr. Bruce Haynes. And I'll tell you a little bit about Bruce Haynes in a minute, as well as our students and the lab techs who keep this place running and who support the work of the students all the time, as well as others who are here. Of course, Ms. Prescott, right? Who is representing Exxon this time and not GGI, Exxon itself, ExxonMobil itself. So the immediate former dean, Ms. Verlene Klaas, very happy to have you back with us. And of course, prior to her, you had Elena, who is now serving as the head of the mechanical lab. I mentioned Bruce Haynes because, one, he has been having some health challenges, but Bruce, so we're happy to see him, but also Bruce was the person who over 5 years ago came into my office one day, and anybody who knows Bruce knows that Bruce is not a man of many words, but he stayed in my office for 2 hours. So that tells you that he was extremely, extremely motivated and very passionate about the particular thing that he was talking about. And he is, of course, a union president, but he wasn't talking about anything to do with the union at the time. He was speaking about the, what he called it, the museum. he said, VC, I have a museum that I'm working in. And he brought this long list of equipment. Of course, poor me, I don't know anything about this, that, lad, this, all these various things. So I said, why are you saying this? He said, no, this equipment was, this lab was donated in 1979 by the British Council. And he was talking to me in 2018 or something, 17, something like that, right? And so that's how this whole project to get new equipment for the lab started, because Bruce was like, I can't teach my students, I can't train students on this equipment. And we really do need to get some equipment in. I did present at the time we had a year-to-year project with Exxon itself, not GGI, Exxon itself. And so I did present this as for funding. They needed $250,000 US to fund everything in the lab. So there are still needs, and I must say that. So let me just say, and one of the things that they need now is to get the power, the electrical power now, to power this equipment, because now it's too powerful for the building. So we have to work on that. But we didn't get the 250, but we got 50. And so the decision as to what to buy with which was 10 million Guyana dollars, the decision as to how to prioritize what was needed was left down to Bruce and the faculty. And so these are 3 or 4 pieces of equipment, 3, that are here is what they decided to purchase. Of course, COVID came in between, and these are not things that you could walk into a store and buy. They had to be procured. The university has a procurement board, and there's a national procurement, so you can't just go buy it. You have to get invoices, this and that. So it has taken us a while to actually get all pieces. 2 of the pieces were already given over, but the one big one was, it came late last year, and so we wanted to ensure that you were here to cut the ribbon. Not only to cut the ribbon, but so that you could have confidence and know that even though it might take us 4 years to do something, that money is there, ring-fenced, nobody's touching it, and it might just be a reason why this was, of course, COVID was a 3-year hiatus for everybody. We couldn't get anything done. So to me, this is wonderful. To the students who are here, thank you. I hope they fed y'all guys some lunch. If they didn't give y'all lunch, I am advising the dean right now, for whoever told y'all to come here at 10 o'clock, then, well, they said they thought they were coming for 10. So they came early, but they need to give y'all lunch. Let them find some lunch and give these kids, right? Me, I said, it's my office, well, then we have to buy the lunch. Whoever is the one that gave the students wrong information, we're so sorry. But thank you for coming. We have to give you lunch. I'll probably give you the money for lunch then, if it's my office. And then I need to figure out who did that. Or maybe I left out a 0 from the 10, from the 1. But thank you for coming. And the main thing is that, we really want to make sure that we're not only speaking about being a world-class university, because I don't believe about speaking about things unless we have a plan and we're actually working the plan to make sure that whatever it is we say we want to do, we can see the steps, even if they're incremental, to getting there. So even though these seem like 3 pieces, it's $10 million worth of equipment. It's 5, right? 5. But, I didn't see that one behind it. It's $10 million of equipment. worth of equipment, so it's not cheap, right? By any means, it's not something you could walk into a store. So I would want to, as always, say that while we're delighted that the students should have the equipment, we also want to make sure that the responsibility for taking care of it, because Bruce's museum pieces lasted from 1979 to 17 or 18 for many decades, right? So it needs to really last so that more students could take advantage of it. I'd also like to acknowledge the presence of Assistant Dean Bashir, who's always here, always answers his phone, no matter what day it is. He's basically really a wonderful Assistant Dean. Thank you for being here, because they're all universities technically on winding down for the semester. And of course, the head of the Department of Architecture, right? Architecture, Dr. Anna Pereira, and of course, other members, Jai and others who are here as well. I'd like to recognize also, I think this is your lab technician, right, in the purple shirt? Mr. Jaidu, thank you so much for what you do and for making sure in advance that these students will take care of everything, because the lab looks great. Maybe it only looked great for today, but okay, well, it's one of the nicest looking labs I've seen in these labs are always interestingly, yeah. So, ladies and gentlemen, please convey two of the principals of Exxon are no longer with us, because it was Rod who was here when this was done. And then, Alistair is the next person, right? And then Kimberly was here, then Deidre, then now Susie. So many people, but I just want them to know that we did it, we have delivered, and that this is a project that I think is something that should be continued, because as you know, we have expanding numbers of students this year with free tuition. We have quite a number of students who are trying to get in, and one of the things that we as a university is in very specific high demand areas are trying to consider is 2 cohorts, right? Because there's so many students that we have, and the demand is so great. Just yesterday, I got a letter from one of the government agencies. They need 3 electrical engineers, right? And this is GPL. Now, if we don't help them, we're all in serious trouble. All right, so I got to think of it. I said, no, I got to figure out how to help, because they will say it's UG, right? They ain't give us the people. But the truth of the matter is, this need is so great everywhere. So we have the students applying. We just don't have the space, and we have to have the staffing capacity to kind of try to see if we could run 2 sets, basically running a night and a day or something. I'm not sure how we're going to do that. This decision didn't come from me, It came from y'all about 4 years ago when we started to see the numbers, and the numbers weren't anywhere near. So don't look, we're not trying to put more work on you. We're trying to find a way to solve the problem. So just so you know, that's it. Or otherwise, we have to do something much, much different. So thank you very much. Take back our thanks. And as I said yesterday when somebody wrote me about something, Exxon has turned out to be the university's best partner. Not only Exxon itself, but all of the other service providers that they bring. So all the SBMs, the Halliburtons, the Techniques, all of those persons those industries that work really closely. Not all of them work as closely, but certainly those 3 that I would have called, and I don't know who else, a baker would work closely with UG as well as the co-venturers. So we really, really thank you. And I'm very sorry for that long thing, but when I get y'all here to listen, you're a captive audience, so I have to tell you everything that I would have written before. But just to reinforce, thank you, and God bless everyone.
Thank you, Vice-Chancellor. Now, please let's welcome Ms. Elena Trim, the Head of Department of Mechanical Engineering.
I hope I don't speak too loud because my husband always said, do not shout. I'm teaching big class, so when I talk, it is very loud and I don't have microphone. Good afternoon, Vice-Chancellor, colleagues, sponsors. I'm very happy to see you here again. Students, lecturers, and guests. And I was asked to give remarks, but I was sitting and thinking, should I say something, really? Because the words cannot express how happy we are with having this equipment donated to ExxonMobil to us, right? But it is, I am not going to be personally using it, but our students are going to be exposed to making things for their final year projects, for their laboratory equipment. Yes, that equipment could be used to create parts and things like that. So you are talking about maintenance. Yes, so we could maintain our equipment. So I do understand that we all appreciate and we very deeply appreciate what you're doing to us for our education, but you also benefit from our education, right? You have our graduates. So, and I heard very good things about their performance, and I'm very proud, to be honest with you, to be not only head of mechanical department, but also the lecturer at the Faculty of Engineering and Technology. So I would like to give a space to our students to tell us actually exactly what they experienced when they were using our equipment in this particular lab, like maybe how long ago? A month or two? So thank you very much.
Thank you, Ms. Trim. And I guess now for the bride, which are the students, the reason why we show up to work every day, the reason why we, our office, the Office of Philanthropy, Alumni, and Civic Engagement, headed by our Vice-Chancellor, the reason why we go out and partner for donations is for our students and for our future and for the development of our country. And so I'll welcome our students, Joshua Joseph, third-year student in mechanical engineering, Ezron Bishop, third-year student in mechanical engineering, and Dwayne Costa, fourth-year student in mechanical engineering in the Faculty of Engineering and Technology here at the University of Guyana, as they come to speak about the student impact and the reason why we're here.
Good, sharp people stuff. All right, so good afternoon, everyone. My name is Joshua Joseph, and okay. Good? Okay. Okay, so my name is Joshua Joseph, and I am a part-time lab technician as well as a third-year mechanical engineering student from the Faculty of Engineering and Technology. So on behalf of the students, the faculty, and the laboratory team, we extend our sincere gratitude to you, ExxonMobil, for this generous donation that will significantly enhance our mechanical lab. So these are not just tools or machines, they represent opportunities for hands-on learning and real-world experience. So previously, with inadequate resources, we didn't have much practical experience. But however, with these new additions, we can now work within our own lab to complete projects. As you know, we can just do more than just read from a textbook. Yeah. So we can now design, build, test, and improve real mechanical components, develop research prototypes, participate in student competitions, which we are planning to do shortly, and projects like making go-karts, which we have done, and solar-powered devices, and also engage in small-scale manufacturing or repairs within the university. So these machines, you have given us, they will enhance our skills and help bridge the gap between theory and practice, and also prepare us for our careers in industry, such as the oil and gas industry, manufacturing, construction, and many other sectors. Thank you.
Hi. One second. Okay, thank you. Good afternoon, everyone. My name is Ezron Bishop. I am a third-year mechanical engineering student, as well as a lab technician in the Faculty of Engineering and Technology. On behalf of the students and the staff, we would like to extend, we are truly grateful to you, ExxonMobil, for the equipment that you have provided us with. Your generous contribution doesn't just only benefit the university, but it also helps the next generation of engineers, technicians, and innovators in Guyana. Your gifts have not only enabled us to complete hands-on projects, but it also allowed us to personally develop our technical skills. We promise to make use of the equipment to learn, to grow, and to carry forward the value of hands-on engineering experiences. Your investment in this faculty have played a significant role in enhancing the quality of engineering education that we receive. And it is not only shaping our individual futures, but also the future of engineering within Guyana. So once again, thank you, ExxonMobil, and for your continuous support and belief in our potential as future engineers. Thank you.
Thank you. Okay, good morning, everyone. My name is Dwayne Costa, a fourth-year mechanical engineering student, and also part-time lab technician here within the Department of Mechanical Engineering. Now, really to add to what my other colleagues have said, we are truly grateful for this contribution from ExxonMobil, and I'm really grateful for it personally because through my years, being a final year student, of course, approaching with my final year's project by itself, I have always been, I should say, graced and blessed with the theoretical aspect and foundation by my fellow lecturers, but have often lacked in the practical theories and applications that can follow. But at least with these machines as such, we can therefore be able to actually execute some skills that we can further practice on, such as the lathe and the Multimatic machine that could offer us basically a platform for us to expand on those skills. And I really don't know what much more to say, but I'm really grateful, and that we, the technicians, along with the future batch of engineers to come, will be able to help them explore those skills themselves. Thank you.
And on behalf of the women in STEM, I'd also like to say thank you to ExxonMobil, evidenced, and we do have women in STEM, evidenced by Ms. Trim here, Dr. Pereira there, and Ms. Class over here. Exams are out and they're probably impossible to reach. All right, please let's welcome Ms. Lasawhna Prescott, the Community Relations Advisor to ExxonMobil. Always a pleasure.
Thank you so much for that introduction. As well, first of all, allow me to stand on existing protocols. As Vice-Chancellor mentioned, this grant or this investment was made before my time, but it is an absolute pleasure to be here today, not just for the launch of the mechanical lab, but to hear the impact it has been making. Outside of this project, in my role as the Community Relations Advisor at ExxonMobil, I've had the privilege of working very closely with the University of Guyana, the students in the UGSBE chapter, a few of the lecturers, Dr. Pereira, Ms. Trim, and even Vice-Chancellor, as we were planning that same Girls in STEM initiative. And I have to say, I am always impressed by the passion that I see that the educators in the system here at the University of Guyana, the commitment to ensure that they advocate for the enrichment and the cultivation of the educational experience for the students. I have been at a few forums where I've had the opportunity to hear Vice-Chancellor speak, and I can tell you, her sitting at the helm, she's always making those plugs to ensure that she gets the support to create a quality experience for the students here. So that's very commendable. As a long-standing supporter of education and the university, we are always thrilled to witness these significant investments that the university, but more so this significant milestone in the institution's journey towards excellence in technical education and innovation. The mechanical lab, we believe, is not just a facility, but it's a testament of UG's unwavering commitment to providing cutting-edge resources, in this instance for its engineering students, advancing science, innovation, and technology. In today's fast-paced world, we can see that technical skills are vital for progress. So the mechanical lab will equip students with hands-on experience, like we've just heard, complementing their theoretical learning and preparing them to meet the demands of the 21st century. This can have a profound impact, we believe, on the academic landscape, bridging the gap between theory and practice with modern equipment. It means that graduates will not only be academically prepared, but will have tangible opportunities to get industry ready. For ExxonMobil, we see education as the cornerstone of development. In fact, STEM is a particular focus area for us, not only to prepare our young Guyanese for the oil and gas industry, but to build their capacity for a much broader outlook in a variety of fields. We know that supporting youth development is investing in communities, in families, and in the future. It is important for us that we have real impacts today that translate to even bigger impacts tomorrow. And collaborating with the University of Guyana has given us lots of opportunities, lots of successes that empower future leaders. So we're honored to be a part of this transformative journey and look forward to witnessing the incredible achievements that will emerge from this state-of-the-art facility. Thank you.
Thank you, Lasawhna, and thank you, everyone. We now move into the ribbon cutting. I'll welcome the students, the heads of department, dean, professor, and Lasawhna.
All right, this is just a simple machine. It's a part of the accessories that you will find in a machine shop. Some tools come sharpened, but they get dull. So how do you sharpen them? You can't rub them on your teeth or on your clothes. So you have to find an accessory that has the capacity that can do the job. Also, the person has to have the capability to also get it done properly. So it's a very critical piece of equipment in the machine shop. We had one that was long overdue for replacement. But one thing I would like to emphasize is that even though it's looking good here, there's wear and tear over time. There has to be replacement. What I do know, over the years, our maintenance budget, it really doesn't maintain anything. Because if I have a piece of equipment we're talking state of the art that comes here, it has to come with somebody who has the expertise to fix it. Since we are not, as technologists and technicians, have the capability, we can do two things. We can import or we can export. We go ourselves to the manufacturers, be trained to fix their equipment, but it has a cost. And we need to ensure that we can put in that input in our maintenance, because travel, transportation, accommodation is not cheap. And plus you have to pay a service fee. So we are grateful for these simple accessories that will enhance our machine shop, but also help our students to learn some skills as they go about doing their practical projects. So I'll rest my case right there.
All right, so this is the Smithy Granite XT 3-in-1 machine. With this machine, you're able to do the lathe, mill, and drill. So, yeah. All right, so with the machine, you can do 3 operations. You're able to do 3 operations, right? This lever here gives you access to switch between the mill and the mill or the drill press and the lathe, which you can use to, which is referred to as the mother of all machines. The lathe is used to create other parts and equipments. Yeah.
You think of a spindle, for example,
Yeah.
it's a rotating machine, and there's a cutting edge. So depending on how far you go, you can create a two-dimensional design as it rotates.
So what we have here is our Miller Multimatic multi-purpose welding plant. The reason why it's multi-purpose is because it does 3 types of welding. You have MIG welding, TIG welding, and arc welding, right? So what we did was just a general setup of the machine. So we have our clamp and our electrode holder. This is for arc welding. Sadly, we didn't get to set up the MIG welding and TIG welding section because we don't have the gas cylinder yet to do any work with that.
What is MIG and TIG?
Okay, so TIG welding, it uses a flux card to do welding operations, and I forgot what MIG welding was. And it uses a, sorry.
All right, so with TIG welding, right? When you perform the operation of welding, it doesn't burn the electrode, right? So what is there to provide a shielding from corrosion, because you're going to heat the material to a high temperature, is argon gas. It's 75% argon gas, 25% carbon dioxide. So it creates a space where there's no corrosion and allow the material to melt down. So in TIG welding, the process goes in such a way that the electrode causes the job piece to melt and fuse together. In MIG welding, it's different in that the electrode burns, right? But the gas that we use in that situation is 100% carbon dioxide. And then with arc welding, it's just electricity with an electrode that is coated with a material that ensures that when it reaches a high temperature, it doesn't cause the job piece to corrode. Now, what happens in that process is that the metal in the middle, along with the heat generated from the electricity, fuses the job piece with this. So it has their varying types, like this is a steel electrode. There are other materials which you can use to do welding with. There are higher forms of steel, which is cast iron. You can use cast iron electrode and so on. So this performs 3 operations. Sorry for intruding, but he asked the question. So yeah, he asked the question. So I just felt the need to answer. Okay. Yes. Thank you.
Well, in the classroom, you speak to the theory about it. For instance, if we're speaking about what project you will be doing subsequently, you give them a blueprint of it. So it has all the dimensions and everything. But it doesn't have the equipment. You have to go in the lab to see it. Now, you, the student who has to do the job, would be in the lab, and you will know which pieces of equipment you have to use to accomplish the task at least, or the project. The bandsaw cuts different types of material. So in order to get the material that is required for you to make the project work, it has to be brought down to size. And the bandsaw is what is used to do just that. The material doesn't come ready-made. So you will have to mark it out, cut to the, I would say, an approximate dimension which is adequate, because there will be waste. But at the end of the day, you have a piece of material that has been shaped prior to, before, by the bandsaw. Then you go to the different pieces of machine tools and accessories to shape, and then you may go and do some fitting work. You use a file, hacksaw, depending on how intricate that piece is going to be.
I remember doing some of this in second year. Are we still
Using the bandsaw?
No, I worked.
Oh, we're talking about.
To weld by the second year.
Yes, that's part of the hands-on.
Right.
We haven't done that because the usual things, but we are trying now to implement into the courses the little practical aspects that will help them to get them hands-on. But the space is always going to be an issue. One of the vision that I had since I've been around is that this space that we have was initially space for doing minor things. But since we are advancing in terms of technology, we need larger and more sophisticated pieces of equipment. It means then that the space that we have is not going to be adequate. Yes, year one. From year one, because remember, you learn the skills at year one, and you take that with you into year two, year three, and final year.
At which stage do they conceptualize the project you were talking about?
Well, initially in the first year, that is just to get them involved in the theories, but it actually starts in the second year where they get more hands-on, because I can't lose a first year student on our pieces of equipment without actually guiding them, giving them demonstrations, and then giving them simple projects that they can work on. That way they make mistakes, but it is not fatal.
Yeah, and I think the students are exposed to, just to add, I think they're exposed to projects that bring out competencies in all these machines. So let's say they have to build a block and measure dimensions and form holes and profiles within that metal. They have to use the bandsaw to cut the dimensions. Then they have to use a drilling machine to bore the holes. And then they're also exposed to, we don't have it exposed right here, but precision measuring instruments as well. And all those things are taught in the class before they come to the lab. So in year, and then they have special lab to do welding as well. So the lecturer would go through all the theory, how the electrode burns and how it fuses the metal and so on. Then they come in here and practice. Okay. Yeah.
So there are more than one project that you do throughout?
Yeah, multiple projects for multiple courses throughout each year.
Yeah. We have a course, right, named Material Sciences. It used to be Material Technology, but we got to rename it because the ABET accreditation. So Material Sciences normally use hands-on experience when it's, we have different types of metal. So you could use welding machine to see how the machine is going to weld different types of metal, how metal is going to react to that, and things like that. That machine also could be used in the same course. So we have different courses in a program that we revised recently. And the machines actually will bring the hands-on experience for students to be tested in the lab, right? So when we teach in the theory in the class, we bring in students to the lab to have hands-on experience, yes. So they could see how the different materials, when they testing, and if they using different materials for the final year project also. Because you remember, it started from fourth year, and then it ran into the final year when they design something for the final year project, and then they design something, they bring something together, they build a machine and things like that. So it is very useful in that purpose.
Thank you for that.
Yeah, and just to say, Mr. Haynes teach some of the courses in year 1, and he prepared a lab sheet and so on for these machines.
Well, thank you everyone for being here. Thank you to the students. Thank you to Lasawhna from ExxonMobil. Thank you, Professor Paloma, for being here. Thank you for negotiating for this through the PACE office. Thank you, Dean, former Dean, Assistant Dean Bashir, and thank you everyone. Acting Lab Tech, who gave this incredible explanation, like he thoroughly understands the equipment. And thank you so much everyone else, Mr. Haynes. Thank you, Sean from SEBI, who set up his PA system. I saw Sean wheeling it over here earlier. Thank you, Sean. Thank you to our electrician. Thank you everybody else for putting this together in our office. Desmond, Latoya, everybody, Tara. We have refreshments out there, and you have a good, blessed rest of the day.